Hi, everybody. This is Miss Weeson, one of your chemistry teachers here at EHS. And in this last unit, we've been learning about different types of chemical reactions. And in today's video, you're going to learn about the single replacement reaction. Now, I'm going to ask that you pull out your notebook and jot down the date, title your notes, single replacement reaction, and write this essential question down. So you might need to pause me real quick to have time to do this. And so here is your essential question. What is a single replacement reaction, and how do we predict the products of a single replacement reaction? We're going to definitely try to answer this question by the end of this video. So one more time, make sure you have your notes out. I'm going to ask that you please include examples within your notes. Additionally, you're going to need that blue periodic table and references. There is a handout on there that you are going to consistently use when dealing with single replacement reactions. So sometimes we jokingly call the single replacement reaction the cheating partner reaction, okay? And if you take a look at the graphic on the slide here, it appears that this guy here in the orange shirt, he's all by himself and he's over here watching this couple dance. And then all of a sudden, before you know it, this guy in the orange shirt is the one now dancing with the lady, and then the other guy was displaced. Well, in a single replacement reaction, one element is going to be substituted for another element in a compound. And this is ultimately going to generate a new element and a new compound. And you can see that is kind of represented here in this generic reaction. Now let's take a closer look. First, go ahead and write down the definition of what a single replacement reaction is. And you can see it right here on the slide. Go ahead and put me on pause so you can take a second to write this down. But it states that a single replacement reaction occurs when one element replaces another element in a compound and the element in the compound is displaced. Or you can also say replaced. Let's go ahead and take a look at a real-life example. In this example, you can see that we have elemental iron, and it's actually going to be mixed with a compound called copper sulfate. And in this particular example, you're going to look at this elemental iron right here on the left side of the arrow, which are called a reactant. And you're going to ask yourself, is the solid iron more reactive than the metal that's in the compound? And you can see here that the metal in the compound is copper, and it's indicated with the green color here. If in fact iron is more reactive than copper, what's going to happen is a displacement or a replacement, however you want to say it, is going to occur. And now look at the right side of the arrow, you guys. Iron is going to replace the metal in the compound. And so now we have elemental copper as a product. So again, you can see here that iron has effectively kicked out copper. And if you look to the right side of the arrow in this chemical reaction, you can see that copper was displaced and is now the element and by itself. And so, of course, too, the iron is now a part of a compound. So in a single replacement reaction, new products are going to form. Now, in the example that we've been looking at, it's important to note that we actually need to look at the state of matter of a substance that's reacting. And sometimes in a chemical reaction, we'll actually write the state of matter down to the bottom right-hand side of the chemical formula. And in this example, we got a starting material of solid iron, which is indicated as a pure element because it's by itself. And then, of course, we are going to use or have some other aqueous compound. Aqueous simply meaning substance dissolved in water, so a solution, if you will. So in single replacement reactions, let's look at this generic reaction again. And in single replacement reactions, see here the yellow letter A is actually going to replace the green letter B. Now, notice how B becomes the pure element after the reaction. We keep saying this. The question is, how exactly does this happen? Or how do you even know that the reaction will happen? So the answer is activity or reactivity. So in other words, if you take a look at the pure element on the reactant side, in this case A must be more active or reactive than B for the reaction to occur. So every time you are confronted with a single replacement reaction, you're going to ask yourself, yes, no, will it go? And then the next thing you're going to do is pull out your blue reference sheet, because we have an activity series that is on the blue reference sheet that you're going to need to refer to when doing single replacement problems. Activity series is basically going to be used for you to determine if one substance is more reactive than another. And so the reactivity series that's on your blue reference sheet goes with single replacement reactions. In other words, you're going to use this and look at it when you're doing single replacement reactions. And so take a look at this activity series here. What do you notice? This reactivity series is showing a ranking of the reactivity of elements. And as you go from top to bottom, it goes from more reactive to least reactive. And this particular activity series is talking and covering metals. All right, let's do some examples. Using the activity series on your blue reference sheet, let's take a look at question number 1, this first example here, and ask yourself, remember, this is the process that you're going to use. You're going to ask yourself if the standalone element, in this case, the elemental aluminum, which is a solid, is this element more reactive than the metal in the compound? So you're going to initially ask this question to understand if this reaction is going to occur. So one more time, is aluminum more reactive than tin? Go over here into your activity series and identify where aluminum is at. I'm highlighting it here with my pointer. Find where tin is at. It's down further on the activity series. So clearly, aluminum is more reactive than tin. And when this happens, that means the single replacement reaction is going to occur. Now notice, after the reactions occurred, that aluminum is now bound in a compound and tin is a solid. Try the next one on your own. Go ahead and pause me. Again, one more time, you're going to use your activity series and you're going to ask yourself, is the standalone element more reactive than the element in the compound? And in this case, since this is a metal, silver, you're going to look at the metal in the compound. So is silver more reactive than potassium? If you answered no, silver is not more reactive than potassium, then it is safe to assume that this reaction will not occur, and therefore it would be appropriate to put NR, no reaction. All right. Additionally, there is one other activity series on your blue reference sheet, and that is dealing with nonmetals. Okay, you can see here it's a small little list of the halogens, and the same thing is going to happen here. You can see that the elements are listed from most reactive to least reactive, and again, you're going to follow the same logic. Let's take a look at this example in our notes here, and you've got standalone diatomic chlorine, and which is a nonmetal, and some aqueous compound. So you're going to compare the nonmetal in the aqueous compound this time. Okay, so you're going to ask yourself, is chlorine more reactive than iodine? And of course, chlorine is higher up, therefore more reactive than iodine. So this reaction is going to occur. And so what you will get is a new compound and a new diatomic molecule that was displaced from the reactants. Most of the elements, you guys, on the periodic table are solids at STP. However, it's important to note that some elements are gases and liquids at STP, not very many of them. And sometimes if you are looking at your periodic table, there's color coding to help you infer what state of matter that particular element is at STP. Let's end this lecture with doing 3 practice problems. Put me on pause and jot these down into your notes. Super important to put practice problems in your notes. What I want you to do is use your activity series and identify the products that are going to recur, if any. Okay, so welcome back. Let's go ahead and do the first one. Now remember, what I've done with color coding here is you're going to compare the standalone element with the element in the compound. For the first one, is calcium more reactive than iron? According to the reactivity series, it sure is. So I'm going to produce a new aqueous compound and a new solid. Second reaction is not going to occur because zinc is not more reactive than magnesium, so it's going to have, there will be no reaction. Lastly, this is using halogens or the nonmetals. So is diatomic bromine more reactive than chlorine? After looking at the reactivity series, we discovered that it was not. Okay, you guys, I hope you have a better understanding on what single replacement reactions are and knowing how to predict the products that are going to form from a single replacement reaction. Thank you so much for watching.